Hey everyone, and welcome to our monthly mechanical engineering virtual meetup with the topic of the month, modern approach to documentation. My name is Anton Fedosiev. I'm the content strategist at Customer Success Organization. Today I have three great guests, Andrew Fakes, Tom Tremblay, and Steve Trudeau. Before we jump into the main agenda, I wanted to remind you the webinar basics. So the lines are muted to reduce the background noise because everything is being recorded. The link to the recording session will be emailed to you, and also you can access it at any time at Customer Success Hub. So if you have questions, please use Q&A button, Q&A panel in GoToWebinar control. And the agenda for today will run through quick introductions, and then Andrew and Steve from Inventor development team will talk about model-based definition and its implementation in Inventor, value proposition, and additional resources where to learn more on the topic. And then Tom Tremblay will talk about the new learning path that he released on modern approach to documentation, where he will cover model-based definition in Inventor and tolerance analysis. And of course, in the end, we'll have Q&A, but please submit your questions at any time because we'll try to take as many as we can during the webinar as well. So what is Mechanical Engineering Meetup? For those of you who are new, it's a monthly series where we talk about the solutions that are already available to you. We share best practices. We invite members of product development team, product management to talk what's going on Autodesk side, share news, etc. So, and it happens every second Thursday of each month. Then we also have something that may be interesting to you in broadly mechanical engineering domain is generative design. So this meetup happens every fourth Thursday of each month, same format. So a quick overview and Q&A about generative design. And also we've got similar events for other disciplines such as architecture, civil engineering, etc. So with that, we'll jump into the presentation from our development team. But before we do so, I wanted to ask Andrew, Steve, can you quickly say about your history with Autodesk and kind of broadly this topic that we're discussing today, model-based definition, documentation. Can you say how your story started with this topic?
Yeah, this is Andrew. I'll go first. So my name is Andrew Fakes. I'm a user experience designer with the Inventor team, and I've been with Autodesk since 2003. Most of that time on Inventor, and you'll see in one of my slides, how much of that time both Steve and I have spent on the MBD project. So when I started at Autodesk, I was hired specifically to help enhance our 2D drawing capabilities. That's my professional background was heavily in drafting and adherence to the drafting standards. So it was kind of a natural fit for me to move into the 3DA and MBD workspace, and that's where I've had some contribution there, directly and indirectly since about 2005. Steve?
Yeah, I'm a software development engineer for Autodesk. I've been with the company since 1992. I started off as a developer on Mechanical Desktop, transitioned into Inventor, working primarily on drawings. Then after moving into management, I started overseeing and working with teams to work on part modeling, assembly modeling, more drawings, iLogic, had some roles in Configurator 360 and Engineer to Order, and in MBD, which has been a favorite project of mine while here at Autodesk.
Yeah, and this is amazing. I'm really proud to have two guests with combined experience in this domain and Autodesk implementation of documentation of like 45 years combined, right? Which is pretty amazing. And with that, I'd like to give the stage to Andrew. So he will share more information about MBD and some of the important aspects of its implementation with Autodesk Inventor.
Excellent, thank you, Anton. So yeah, let me get the presentation mode here. So we're going to start with, excuse me, everyone seeing my screen okay, Anton?
Yeah. Yes.
Okay, very good. So this is an image we'll start with. We'll revisit this image and do a little bit deeper dive in a few minutes, but this is kind of our roadmap, so to speak, you know, kind of the journey that we expect a lot of you are on and that we want to help you advance through. So, you know, a lot of you are here because you're, you know, Inventor or Fusion customers and users, and so you're in this, the second row there, design classification code 2, where your single source of truth for product lifecycle, manufacturing, quality, everything is derived from your drawing. Your drawing is the legal document. Your drawing is where anyone goes to if they have any questions. We're acknowledging, of course, that 2D drawing, as opposed to being created, you know, from scratch as you might in AutoCAD with DCC1, you know, the drawings you're creating are derived from a 3D model. Where we come in, you know, Steve and I with our MBD tools is, you know, as you start to look beyond DCC2 into 3, 4, and 5. So keep this picture in your head as we move forward. We'll revisit it in a minute or two. So Anton, could you cut off the first poll?
Launching the first poll, and do you mind rating your, you know, approximate level of GD&T adoption? And with the options available, what is it? And all up to full adoption of GD&T technology. Please just click on the screen, and I will share the results in 5 seconds. Okay. About to end the poll, and here are the results for everyone. So as you can see, mostly the audience is in early stages of the journey. So
Yep.
Probably it makes sense to also say a little bit more about what it is, how it works, and how to get on the path.
Certainly, yeah. So I'll talk about that real quick, and then we'll move into some of the definitions. But GD&T is, as we understand it in America, it's geometric dimensioning and tolerancing. In the ISO standard, and in Europe, I believe it's referred to as GPS. But basically, it's rather than, you know, traditional dimensions and whole notes and so forth, it's symbolic based tolerance specification, and it's that technique using GD&T, which is you know, has a pretty long history and a pretty robust set of standards behind it in both ASME and ISO. It's using GD&T controls that really let you achieve the real MBD vision as we understand it. So we'll talk a little bit more about that as we go through some of the definitions here. And with that, let's take a little bit deeper dive on terminology, and I'll pass it over to Steve to review this slide.
Yeah, so for MBD, yeah, terms get intermixed within this this industry, MBD, PMI, GD&T. So we just wanted to start off with laying the foundation of the terminology here. So MBD to us is your 3D model with the embedded GD&T or semantic information about that model that you're creating. PMI is the semantic information, that's the GD&T, maybe it's your surface texture symbols, material information that's kind of embedded into the model itself as you're developing that in your 3D CAD system. 3DA to us is really all those other annotations that are human readable that go onto your model in the forms of, you know, just general dimensioning, leader text, general notes that show up. And then MBE is more of the broad-based term, also referred to as Industry 4.0. This is the digital thread of your model, your 3D model, that after you've created that in your CAD system, it transforms downstream into your manufacturing processes. There's a product life cycle that goes around that model as well. And that, so the MBE term is used for all of that. Anything to add, Andrew?
Yep, thanks, Steve. I just wanted to underscore, again, revisiting the topic of GD&T and how it contributes to model-based definition. You know, getting to the point where you can take your annotated model and pass it directly into these downstream systems like like CAM, inspection, and so forth, only is achieved by using GD&T as as a tolerancing mechanism in your models. Because GD&T and GPS are so tightly controlled through standardization, that makes it possible for the CAD industry to standardize on it. And there's a number of formats that already support the GD&T implementation as product manufacturing information. So just a quick history of how Steve and I have been contributing to the MBD solution during our time here at Autodesk. So 2005 was the first time that I understood that, I ever heard the term 3DA or, understood it as a priority from our business leaders. And, we actually spun up a team in 2005 and started investigating, where the industry was and what our customer requirements were. And like a lot of projects outside Autodesk, that project was started and then scoped really before it ever got going. But we did learn that, we wanted to be able to give users the ability to manage 3DA visibility and camera views, save camera views using view representations as was available in assembly. So as a result of that initial project, we ended up getting design views put into parts in Inventor R11. Project got started again in 2008 with a pretty sizable team, both Steve and I involved, and that project was scoped before we could ever release anything. Although as part of that effort, the pretty substantial development team was successful in porting over a lot of the annotation architecture and object models that were in 2D and getting them moved into the 3D space. So that, while we didn't create anything customer facing, we built the foundation for our MBD solution during that time frame. 2014 is really when we got serious about it and committed ourselves to releasing the solution as soon as possible. So a pretty substantial team got formed in 2014 with the goal of being able to release a fully fledged MBD solution in Inventor 2017. We didn't make it. We thought what we had wasn't quite ready for consumption yet, but we were able to provide 3D PDF in Inventor 2017, followed directly by in 2018 our big MBD investment, where all of those tools you see in the annotation ribbon basically showed up. And since then, we've been adding capabilities and functionality, ease of use, continuously in both our dot releases, which come out twice a year, as well as our annual releases that are available in March. So currently, today, we continue to invest in our MBD solution. We have a number of partners, customer partners, who are aggressively moving towards an MBE solution, Industry 4.0. We're working on QIF export. So QIF stands for Quality Information Framework. It's a fairly new file format that's specifically designed for MBE and tracks lifecycle and inspection of your product. We're hoping to get that available and made available as soon as possible, but we can't, of course, commit to a release right now. There's lots of possible things we could be doing in the future. We're certainly interested in hearing feedback on where you would like us to go. We could double down on our GD&T implementation for those that are ready to move into that full digital thread kind of environment, Or if you want us to invest in the 3DA tools, just double down on creating human readable annotation, getting our weld symbols, our 3DA weld symbols part of this architecture, sheet metal annotation, for example. We should be investing a little bit more in our interoperability with CAM and CMM. So really, we're going to be looking to our customers to help guide where we make future investments. Steve, anything to add?
No, good overview of the development cycle here. It seems long, but
it is long.
Yeah. But there is something in the product today. It's usable. Yeah, fully functional.
And it's the time for the second poll, where we will, just to understand the level of further narration, where you are with Inventor's implementation of 3D annotations and MBD. Have you tried it or not? Do you use it frequently? Just click on the screen. And I'll keep it open for 5 more seconds and then share the results with everyone. Okay, so I think that we're good. So let me close the poll and share the results. They're pretty in line with the first poll. So the level of adoption is relatively early, right? With just 14% use MBD on more or less regular basis. Okay, so this is good information for us to for the next slides or the accents that we add. Good. Let me give the stage back to Andrew and Steve.
Okay, thanks, Anton, and thanks everyone for participating in that poll. That's very helpful. Okay, Steve, we'll go over this slide for you.
Yeah, so I guess what would have been nice here is to show a graphic of the Inventor screen showing where our annotation tools for the MBD tools are at. We'll see that in Tom's presentation and learning material. But our the value proposition that we're offering right now in Inventor, annotation authoring, right? So being able to apply general dimensionings, whole notes, leader text, surface texture, and the GD&T annotations. And taking a step further, we have an embedded advisor tool that's in the product as well, so that you can make or apply GD&T according to the rules and standards that are in place today. It'll keep you from making mistakes or making nonsensical manufacturing information and putting it on your model. So the advisor, which we get from Sigmetrics, a long-standing vendor with GD&T, is who's providing us this technology. Tolerance features, tolerance analysis. This is another tool that Sigmetrics provides us, allowing us to do a 1D stack-up analysis in your assembly models. And the last bullet there, face coloring, helping you to identify which faces are fully constrained and which are under constraint to help you through the model as you're defining your fit and function for your part. The two models that are shown there, one is on the left, is basically your 3DA, your general annotations, dimensioning and leader text that you might see on a typical drawing. We're allowing for that in your 3D model space. And the one on the right is fully defined using GD&T, semantic information that's embedded in the model, so that when you're sharing that model downstream, whether it's to STEP or JT, maybe it's your CAM systems or CMM inspections, that semantic information is being passed along. We also allow for recovery of these annotations and GD&T into your drawings, so that you don't have to do it twice. If you apply it into your model, you can create your drawing and then recover those into your drawing. 3D PDF is a way of externally sharing your Inventor models out to customers or other viewers. 3D PDF allows you to see all the annotations, show your model, and it's in 3D so that you can spin the model around and interrogate it using measure tools that are in the Adobe Acrobat viewer. 3D DWF is the Autodesk format, so it's we got that fully functional, and where you can export your annotated models to that. Shared views. This is available to product design manufacturing collection subscribers, where you can actually take a snapshot of your model, share it up to your colleagues. They can comment and mark it up and send you back feedback on what you've got. And then STEP and JT are derivatives we can export to, and typically those are the industry standard formats that are sharing downstream with your manufacturing team.
Yeah, and as a whole, you mentioned or you made a comment about Industry 4.0. Maybe, Andrew, you did this comment. So can you say, is it one of the stepping stones on the path to Industry 4.0, or how would you think about MBD very broadly?
Oh, I see Industry 4.0 as effectively synonymous with model-based enterprise. So model-based enterprise talks about, MBD, model-based design, is very CAD-centric, and that's of course the space that we live in. Where we provide the tools to author model-based definition and three-dimensional annotation, and give you tools to embed that information in the model. But just having that in there, just having that information in the CAD model isn't enough until you can realize the benefits for moving your tolerancing schema into the model itself. And that's the digital thread. That's being able to take that model as the single source of truth and pass that data directly through all the downstream systems without ever having to worry about a drawing, without ever having to have a human read something in and then type it back in, which is very error prone, of course. So as I mentioned, model-based enterprise is, as I understand it, synonymous with Industry 4.0.
Mm-hmm. Excellent. Thank you.
Certainly. One other thing I just underscore, with the embedded GD&T advisor that we, as Steve mentioned, licensed from our partner Sigmetrics, we offer GD&T annotation controls in the 2D environment, and anyone who's ever tried that will understand that they can create nonsensical GD&T controls. They can, you can specify a tolerance or a tolerance type that just doesn't make sense. There's no restrictions in the 2D side. There are certainly restrictions on the 3D side. You can't, for example, reference a datum that you haven't defined yet. You can't have a secondary tolerance be greater than the primary tolerance. So again, the GD&T is what makes PMI possible, and we have to be very rigid with our implementation of GD&T, and it has to be exactly as ASME and ISO understands it. So that's the major difference between the GD&T controls in 2D and 3D. So here we are again at the dataset classification code table. I just want to mention that this image here comes courtesy of Brian Fisher. Brian Fisher is a GD&T and model-based definition consultant out of the Portland, Oregon area. He's done a lot of training on GD&T. He sits on the ASME board and is responsible for developing a lot of standards around model-based design and model-based enterprise. So the ASME Y14100 is basically the engineering drawing specification. It's been around for quite a while and encompasses the MIL standard around drawing documentation. And these details here, section F, Appendix F, were added in the 2013 version. There is a 2017 version available. I don't have that copy of that, but I would encourage anyone that's interested to get a newer copy and just review it. And this basically just acknowledges, like I said, from the standards standpoint, that 3D models are a valid replacement for 2D drawings as the single source of truth, as your your company's manufacturing currency, so to speak. When we, what we hope to be able to do is provide tools to get you to any one of these classification codes beyond number 2, where I expect everyone is at today. A lot of people are here because they think that they want to go drawingless. Just going drawingless is a big motivation factor for a lot of people who approach these tools. It's really much more nuanced than that. We've found, Steve and I, in talking with the customers who have gone down this road, that no one ever really goes drawingless. It's an aspirational goal that it's never really achieved. And this is even true of companies that have been in the MBD space for a generation now. But the tools are going to be there, so you'll start to rely less on them, especially for individual piece parts. And we want to give you those tools to get you to that point where you can stop using drawings if you feel necessary. We mentioned that one of the value propositions that we've created is drawing recovery. So all those annotations that you create in 3D model space can be recovered in a drawing. So if you're making the investment in annotation in a model, and every once in a while you still need a drawing, we make it easy to create a drawing, and we're actually working now on enhancing that experience and being able to, in a more automated fashion, take the work that you've done authoring 3DA and MBD in the model, and in a much more automated fashion, creating a traditional 2D drawing with that information. Okay, last poll, Anton, if you will.
Yeah, last poll based on what Andrew just shared. So as a aspiration, so where do you feel you want to be, and where your company want to be in what classification code or what maturity level are you trying to get to? Okay, good. So we're really close to closing the poll and sharing the results. So let me do that. And it looks like the biggest percentage of the audience is voting for maturity level 4, which is still full definition in both 2D and 3D. So 2D remains important for the audience.
Good, thank you. Yeah, no surprise there. That's certainly in line with anecdotally with what we understand from a few years of talking with customers, and that's good. Like I said, we are currently investing in in making drawings easier to create if you've taken the time to invest in 3DA. So again, thanks for participating in that poll. And I'll just wrap up here by referring you to some additional resources if you're interested. Action Engineering is another MBD consultancy. They're based out of Golden, Colorado. We've referred a number of customers to them. They have a lot of experience with MBD, particularly in the aerospace and defense industry. Aerospace and defense have really blazed the trail here for MBD adoption in the manufacturing market. And I encourage, at least visit their website. They put on an MBD conference every year that Steve and I have attended the last couple of years. Really good networking opportunity to learn from other companies and understand what their journey has been like with MBE. There's a couple of archived classes from previous AUs. So I encourage you to go to the AU website with your Autodesk credentials and review those materials. That first one there was actually taught by the president of Action Engineering. We invited her in to do that class, and it was a really good overview. When Steve and I want to talk to customers about anything really, but MBD in particular, first place we go to is the beta forum. So if you're not members of the beta community and you want to be able to contribute to this conversation or learn about where we're going, I certainly encourage everyone to visit the Inventor beta forum. There is a dedicated MBD topic area there where we can discuss requirements, questions, and so forth. The National Institutes of Standards and Technology also puts on a conference, an MBD conference every spring. A couple of us from Autodesk have been there. I think it went virtual this year, but that also would be a good resource. And of course, the Inventor Idea Station is a good place to submit ideas, submit requests, and gather support for requests, as well as understand where other people have needs, not just with our model-based definition tools, but with across the product. The Inventor Idea Station is a resource that we refer to a lot when we want to understand what customers need from us. Steve, anything to add there?
No, these are the major things where you can learn about MBD and 3DA. Yeah.
Okay, so finally, I just before we kick back to Anton, there is a question area there. Steve and I will be online, and we can answer those questions throughout the rest of the presentation. So please feel free to ask questions there, and I'll thank you for your attention and go back to Anton.
Yeah, thank you so much, Andrew and Steve. That was a great kind of insider view into what's going on with MBD, its history, and that was amazing. Thank you so much for sharing this with us. So as a reminder, I posted some of those links that Andrew and Steve shared in the chat window, but also please take a look. The presentation itself, the PDF version, is available for download. And with that, I'd like to give the stage to Tom Chandley, who's our frequent speaker at the meetups. And this time, Tom will talk about the new learning path about modern way to documentation and how to learn MBD and tolerance analysis, and how to get from the maturity level that you indicated as your current level to where you want to be, the fully defined 2D and 3D models. And Tom, I'd like to start, of course, do you mind saying a little bit more about you, but then I will have my first question to you.
Sure. So I've just been working around the design software for a long time. In fact, I was working with the Autodesk 3D tools before before they put them together as mechanical desktop. So it's been great. The paperless world has been promised for decades, and it's been really nice to see how the way the 3D annotation tools are coming together is going to make it possible for people to start working their way that way. People, I think, have been reluctant to even try it because they think that once they dip their foot in the pond, they have to go completely in. And that level 4, where it's going to be a complete 3D and 2D documentation, I think is going to be the reality for a lot of people. And it's really amazing to see how well the tools are doing. Of course, there's always going to be room for improvement and enhancement, but the way they work is really quite nice. And that's some of the things we'll be talking about in the course and in the discussion today.
Yeah, and my first question, right, because there is a lot of details in features, buttons, in MBD 3D annotation, tolerance analysis, but from the final result standpoint, what kind of quality of the final result that you get with those tools? Do you get higher quality design? Do you get easier manufacturing models? What is it for you? What is the bottom line?
For me, it's starting to kind of break down the paradigm. For years, I've known people who've been able to visualize three-dimensional objects fantastically. One of the great unspoken gifts that 3D CAD has been to allow people who can visualize in 3D, but have never been able to effectively communicate using orthographic projections. I'm a person, for example, who first angle projection makes much more sense than third angle projection to me, but of course I'm in the US, so throughout my career, I've had to always remind myself how these projections should work. With 3D annotation coming about, you're going directly from the idea of a physical model and what it has to do to perform a task to communicating to people what the limitations on the size are, or what the tolerancing can be, without having to have someone look at a 2D drawing and then try to reimagine it in 3D in their mind, or imagine how they're going to have to set up the tooling, or how they're going to have the fits to other components in 3D, having to translate that from a 2D document. So it cuts that 2D to 3D back to 3D to 2D back to 3D translation out of it. And I think that's going to be a big boost for productivity. Of course, there's going to be a generational element of people who've, come up only working with 2D drawings, that might find some discomfort with it. But I think as companies start to make the move up the levels in DCC, I think they're going to be surprised at how open people become once they actually try it.
And it's a great transition to the learning path that you recently published. So do you mind talking a little bit more about it and actually demonstrating some of the in-product capabilities, how this 3DA annotation works in Inventor?
Absolutely. So we've got a fairly limited amount of time, so I'll just talk about the course, which is Modern Approach to Documentation. It's a course up on the Autodesk Consumer or Customer Success portal, where all of the other courses are. It's broken down into 4 major sections. The first one, 3D annotation, and then, it's of course going to have all the videos, the step-by-step instructions and data sets. There are also quizzes to assess how you're learning with this. It's broken down into these major groups. So there's going to be annotating and sharing a 3D model. So if all you want to do is basic 3D annotation, maybe instead of sending a 2D drawing to a customer, you send them a 3D annotation so they get a better feel for it. Then, of course, there's the detailed 3D annotation, the more production-oriented elements. So we get into that. And then we talk about the different options for sharing this 3D annotation to people who don't have Inventor or Relieve in any CAD system. And then there's another whole group of topics that I think there's 3 videos around tolerance analysis. One of the questions in the Q&A was referring to how, do we deal with tolerances when they stack up in the assembly. The tolerance analysis tool, which is part of the product design and manufacturing collection, can really help inform your individual component design from the assembly, which is really kind of how we need to be looking at it anyway. So let's take a look at some examples of these. The first one we'll take a look at is just simply annotating a model. And as I referenced briefly, if you have someone who just needs to understand what the size of your product is, you don't want to give them maybe not all of the intellectual property, or maybe you want to help them understand how they need to take your product and attach it to something else. 3D annotation can be kept at a fairly simple level, but there are a lot of great tools built into the software to help make the communication very clear. Let's take a look at a couple of examples. For example, now we have one dimension. We'll use just the dimension tool from the Annotate tab. Clicking on an edge and a face will give you a dimension, just like you would be getting in a 2D document. Now, in this case, it doesn't have the correct orientation that I want. So there are some right-click overrides if you place the dimension that will allow you to change the annotation plane, or there are keyboard shortcuts. Everybody loves keyboard shortcuts, where I can hold Shift and select the YZ plane, and it will set that dimension in place. You can build these dimensions out. You can also change the position of them as they're applied. Let's take a look at a couple more examples. So selecting that edge again, we get a 4-inch dimension. Selecting another edge, we get a 7.3 width. So it's going to build these out. And you'll notice that we're getting a menu in the upper right every time we place a dimension. We'll take a closer look at that with some other options. Now what I'd like to do is get an overall length. Of course, I'm trying to illustrate this for a customer. I select a curved edge, I get the radius. If you select the other curved edge, it's going to find the center points. Using the Shift key, I was able to change the orientation of the dimension itself. But that's not the dimension I want. However, the dimension I want is available in a sketch. So if you access your parametric sketches, you can promote dimensions directly from the parametric sketches into the 3D annotation. So while there might be some limitations and still some room for growth in the 3DA tools, they're giving you access to the intelligence that's built into the original design in the first place to help you continue to develop. There are a lot of other tools such as hole notes, where you can select the hole, and not only will it give you the information about the hole, in this case, it's even giving you the hole count. So once again, the parallels to the 2D documentation are there. However you want to visualize the annotation on the model in 3D, you're approaching it very much the way that you would in 2D, but everything's in one place. You're not having to flip from view to view to view to view, and maybe even from page to page to page. It makes it much nicer. Now, later on in this course, we get into the ability to build out design views to limit what annotation is available, and that can translate into a shareable file as well. So it makes it very nice. So again, just regular leader notes, really nice, clean way to share your information with others. And I don't know if you noticed, but as the model was rotating, the text always remained legible. So when you need to get into the more manufacturing oriented, the more product development oriented side, that's when you're going to get into GD&T using features to place dimensions rather than just using edges. You can add additional callouts to a specific dimension. You can incorporate fits or tolerances, however you need to do it. And the tolerance advisor that was mentioned briefly before is an incredibly useful tool, as it will guide you into what else your model needs for definition. So here we have a model that's pretty much just at the 3D annotation stage. Let me see here. All right, there we go, sorry. We'll apply a primary datum by selecting the bottom face. Again, up in that upper right corner, we get the information around what that definition is. Let's make sure that's playing. There, I think we go. You can go up and tell it whether or not you want to apply a datum to that. You can choose which profile callout or which control you want to apply your tolerance. You can also make other modifications and then just apply it. Now, as soon as you do that, that's when the tolerance advisor will appear. It will let you know there are some external dimensions that were applied. That's that 11.3. One or more of the surfaces is unconstrained, which makes perfect sense since so far we've only really constrained one surface. And now not all of the degrees of freedom are constrained because we only have one datum. So this model could be spinning about, it could do all sorts of things. And the datum that we do have is not referenced by another dimension. So just kind of having this reminder up in the corner that you can use as kind of a sanity check to make sure that as you're applying information to this model, that you're doing so in the correct way. So we'll use the feature advisor or the tolerance the tolerance feature, and we'll drop this in. You'll notice that the fit is already in place. That comes from that feature. So if you apply individual tolerances or fits to your features in your 3D model, the 3D annotation is capable of extracting that information and bringing it directly in. You'll see that it's also applying a datum to this feature. You can set up the tolerance and make any other changes that you need. We'll apply that one. And then I think we're just going to do a couple more. You'll see that the reference to A has been removed from the tolerance advisor not being referenced, but now there's no reference to A and B. So as you continue to add features, it will continue to collect. Of course, you can go into any of these features and make modifications to the individual tolerance for the controls or for the dimensions. And that's as simple as clicking on the element that's on the screen and making the modifications. All right. I missed a slide here. Pardon me. All right, Anton, it's telling me there's a poll 4 here.
Yeah, and the poll 4 was about the types of documentation that you use to share with your customers or with your own internal manufacturing team. So do you
Okay.
mind, as before, clicking
Not at
the
all.
option that you use, right? What formats do you expect your customers to consume documentation? And it could be 2D or 3D PDF, DWF, whatever you use with your external or internal customers. Okay, and thank you so much for voting. It gives us important information for the next slide where Tom will talk about sharing this information.
All
Okay,
right.
so I'm closing the poll and sharing the results with all of you, and it's kind of also in line with what we saw in the previous polls, right?
Yeah, it makes perfect sense, and that's exactly what I would think people would be doing. So let's talk about sharing that information. So sharing the 3D annotation, moving it out, of course, it was mentioned before, we have 3D PDF, DWF, you'll have the ability to do your share files. And people have had commented in the questions that the ability to be able to still create these 2D drawings is going to be critical. So rather than having a lot of repetition of effort and a lot of or redundant work, we can also use the 3D annotation to help develop the 2D drawing. So let's take a look at how some of this works. So we have created a series of design views, front, right, drain, that limit which annotation are part of them. So if we go to create a 3D PDF, we can choose which views are included, what metadata is included, so you can choose how much information you want to give to the person who's going to be consuming this. You have the 3D view. You can also have the customer pick these other views, as well as influence the look of the model. But by picking between these views, you see how you can define how customers or consumers will be seeing what the data is. And of course, we have the ability to export out to STEP. And now that there's an enhanced version of STEP that takes 3D annotation into account, we're able to access that as well by using the 242 standard. Okay. Once that's exported, let's take a look at leveraging the 3D annotation in 2D. So we'll begin to create a new drawing. And for those of you who've been using model dimensions, your sketch dimensions in drawings, this workflow will be very familiar. So we'll rough in a location, we'll place a view, and then we'll retrieve the model in annotation. But there's a 3D annotations tab now. So we can choose whether or not we want to include hole notes, dimensions, any surface callouts, any datum references, or any GD&T references. And now you've taken all of that information that you built into your 3D annotation model and just used it to detail out your 2D drawing view. So saving a lot of extra effort. So for those of you who want to produce, and that was the majority, both 2D and 3D, there's your answer as to how you can reduce your amount of work to do both. Then finally, the last thing we want to take a look at, or that's part of this course anyway, is tolerance analysis. It's included for the product design and manufacturing collection users. It can leverage assembly constraints, or let's say you have to do a tolerance stack for something you're purchasing and you want to review it, or perhaps you're creating a component in the context of another design, or maybe you just didn't assemble the components in a specific way. You can build out your tolerance analysis. It can extract information from the components, so tolerances that are built into the features of the components, or it can also extract information in the 3D annotation. It gives you the ability to take a look at your components in context and see what's possible and analyze what's going to happen with these components using a worst case scenario, the root sum squared model, or different statistical models. So let's take a look at that. So here in an assembly, we've gone into the tolerance analysis. We'll say that we want a new stack up. Now, the one that we'll use here is the shaft and bearings constrained between the cover, a gasket, and the main mounting plate using Inventor constraints. So we can choose the initial components that will be, or the initial faces that will be the basis for the analysis. We'll select the annotation plane, and as always in Inventor, you want to follow the red arrows that will let you know what's expected next. We'll place where that dimension location is. We can either use those assembly constraints and joints, or we can go and start using the select approach instead if you want to pick individual components and constraints. Here it's found 4 different constraint paths. Because of where I want to place the annotation on the model, I'm going to use the one at the top that uses the top references and then have it place those tolerance stacks. So on the right, in the panel on the right, you see in the upper section, there's a pane that shows all of the tolerances that were referenced in this stack up. At the bottom, it shows us the results. And at the bottom, in this case, at the moment, it shows that we have a lot of potential for issues. So what we can do in this, and this is why this is so powerful, is first we can go back and look for things that, like for maybe on the purchase components that really aren't going to be that loose. So we'll take some of that slop out of there. And then we can start taking a look at the individual features of our models that perhaps we applied a tolerance without thinking about it or not really sure what we wanted. So we just roughed something in, and we can go back and start modifying it and saying, okay, if we make this part just a little bit more expensive by making it a little bit more precise, what does that do to the assembly? Or can we loosen up other components, make them more affordable to build, and still get quality results? You can see which of the constraints or which of the tolerances are contributing most to the stack up and go in and make modifications. You can change the classification of tolerance as well as the value of the tolerance. And once you've got a feel for how your assembly is going together, you always want to remember that there's other ways of looking at it. So this is worst case. If you want, though, you can change from reviewing your worst case to, in this case, let's go to a statistical. Well, this is the RSS first. Then we'll go to a statistical, and we'll go for the percent of yield. So if we start making these parts, what percentage of them, if we just grabbed them out of a bin, would go together based on the tolerances we have? And right now it's 99.9999% would still be able to work for our design. So excellent results there. There's one other thing, and there was even a question, I believe, asked in the Q&A section about the use of assembly instructions. We did another course a few months ago focused on visualizing your products, and in that was a section on animate assembly and service instructions. So I would ask you to go take a look at that, the Visualize and Animate Your Product course. It's already on the Customer Success portal. So Anton?
Yeah, that was amazing, Tom. Seriously, I just realized that when we just do our traditional 3D design and 2D drawings, and very often we just define the geometry, we visualize the geometry of the model, right? But not necessarily thinking about how is it going to be manufactured, how is it going to be assembled, And some of the tools that you've shown actually bring it to the next level, right? So that's I think that's amazing. And also there is a way to learn it now with the free courses. I posted the links in the chat, and also those same links are available in the presentation. So I'd like to summarize it, and let me share my screen in this case. Let me go to my screen. Okay, here we are, and some takeaways and next steps. And number one is actually take a look at all other courses that we have, right? Because they take you in 2D world with AutoCAD. How do you transition to AutoCAD Mechanical, or how do you take advantage of some of those tools available there? Then we talk about transition to 3D simulation, CAM, and all other aspects of the journey of typical mechanical engineer. So those courses are available now. Many of them are produced by Tom, who presented today. So check it out. So I posted the link in the chat window. Then also just a quick piece of news that we will have a free virtual manufacturing summit in August 25th to 27th, free registration, and it will talk about additive manufacturing, generative design, CAM, and molding. So register if you are interested, and I will post the link in a second. And in general, what are some of the next steps that you could possibly do? Take a look at the courses that are published by Tom. Take a look at the resources shared with you by Steve and Andrew, by our development team. Provide the feedback about the tools on Idea Station, and register to the next mechanical engineering meetup, where we will talk about collaboration and data management. And we will specifically talk about two main tools that could be used, more like desktop collaboration in Vault. And we will also talk about some of those advanced collaboration modes with external providers and supply chain using Fusion Teams. So this is the topic of the month in September. So everything is available in the chat window. And also, I'd like to get back to Q&A for a few seconds. I do believe that we answered most of the questions already, right? Because the stack is empty. But I wanted to ask Andrew and Steve, who answered a lot of those questions, like, did you see any trends? What are some of the more frequently asked questions that you'd like to mention?
So, in my experience, in talking with customers about 3DA, they're one of the problems that we encounter is there typically isn't a trend. The spectrum of questions is very broad, which makes it very challenging to understand, where we should prioritize our future investments. And the questions I've been getting here are really no different. Everything from data management, revision control, standards compliance. Just a word on standards compliance. There are a couple of 3DA standards, including ASME 14.41. That standard was basically derived from some other CAD providers' existing implementation. I forget which one. It might be Unigraphics, it might be Ideas, I can't recall. But basically that standard was basically derived from some other CAD vendor's implementation. And we really haven't found standardization, at least among our customers, around 1441. But we do, so we're not investing in our solution specifically to be compliant with 1441 and its ISO equivalent. But where we do make investments, we do refer to that standard to make sure that any tools we do add are compliant generally. But we always take customer requirements as a first priority beyond just blind standards compliance of 1441. Somebody asked about revision control. What does revision control look like in an MBD space? I don't have a good answer for that. I've got that question a number of times. everybody does revision control, even in the 2D world, a little bit differently. Needs are very different there, so it's hard to understand what the right answer is. Very little standardization around revision control. iProperties are a good possible solution. iProperties are available in 3D PDF publishing. They're available in DWF. So any information you embed as an Inventor iProperty can be published in those formats. A couple questions about iLogic. So right now we don't have a big iLogic investment in 3DA, although everything is available through the API. We're continuing to invest in iLogic generally, and exposing more tools. We did a lot of investment with iLogic for 2D drawings in the last couple of years, and I expect we'll be tackling 3D annotation sooner rather than later. Steve, anything you want to add?
Somebody was asking about the benefits of MBD besides the ability to not create drawings. I think there's a lot of benefits. Not creating the drawing, the one source of truth stays with the model. You're able to share that semantic data downstream to your CAM operations or your inspection operations. Being able to share that information as a 3D model out to outside vendors for quotes or something like that. Yeah, drawings is another derivative of that model, and you got to keep it in sync. And once you produce that drawing, who knows when it's out of sync with the model. So you got to have processes around making sure that you're staying up to date.
And since we're running out of time, I think we have the time just for one more question, and we have one open question in the stack about the BOM process in 3D PDF and 3D annotations. What are some of the tools that could be used for BOM?
Yeah, I saw that. So we don't have explicit BOM support right now. 3D PDF, you can actually configure your 3D PDF template to kind of build a BOM from the component iProperties. So I believe our sample 3D PDF template demonstrates this capability, but that's not a direct read of the Inventor BOM. It's just a collection of file properties. It's more like a parts list than a BOM. So we have further investments to make in our BOM solution with MBD.
All right, so with that, we ran out of time, and huge thanks to everyone who joined today, and also to our speakers who shared also kind of the internal information about how the solution was developed and also ways to learn it. So thanks to everyone, and please provide your feedback about this session in the survey, and join our next meetup in September. With that, we're closing the session. Thank you so much.